Now we will discuss test series 4, question number 44. 2 mark question. So it from the topic measurements. So first we will consider a first order system. So an RC network is always a first order network. I am marking all the components. So this V out. So V output is Vi times 1 by AC by, if I am writing in S domain, by total resistance R by 1 plus, or impedance R by 1 plus AC. So if I solve this, what I get is V output equal to Vi times 1 by SRC. So we know that time constant is nothing but product of resistance and capacitance. So nothing but V output equal to Vi times 1 by tau times S. So if I convert it into, if I want to know the magnitude of output, so what I get is, if I split it into real term and imaginary term, J tau, so which is nothing but V output equal to magnitude of output voltage in terms of input voltage is 1 by under root of 1 plus omega tau whole square. So this is the magnitude. We need to calculate what is the phase. So here you can see V output equal to Vi times 1 by 1 plus j omega tau. So the phase angle introduced here is, for the numerator it is 0 degrees because the imaginary part is j times 0, and minus tan inverse of imaginary part by real part, so which is nothing but minus tan inverse omega tau. So from here we can generalize that whenever for a first order instrument the output will be, or I naught will be, input times 1 plus omega tau whole square, and if it is a sine wave for a first order system, for a first order instrument, for a sine wave input, what we get is sin theta minus phi. So here phi is nothing but minus tan inverse sin theta plus phi. So what ultimately it will be minus omega tau. So we can generalize it. So for a first order system is energized by a sine wave, what we get is an output response is the input magnitude gets of, if I represent I sine omega t is my input, so my output will be the output will be input magnitude scaled by 1 plus omega tau whole square, and there will be a phase shift introduced by phi. So now given input is, we are given with an input of 2 sine 2t plus 0.2 cos 8t. So now we are asked to find the response of a first order system for given input. So now we will use principle of superposition. So let I1 equal to 2 sine 2t. So we will calculate what is the response for this input. So the response will be I1 equal to 2 by under root of 1 plus, here the omega is 2, and the time constant of the circuit is how much? 0.15 whole square into sine 2t minus tan inverse omega into 0.15. So if I solve for this, what I get is I1 equal to 1.9156 sine 2t minus 16.7 degrees. So now we will take the other input, which is 0.2 cos 8t, which I can represent in terms of sine as minus 0.2 sine 8t plus pi. So now once again the response remains the same. I2 equal to 0.2 by under root of 1 plus, here omega is 8 and the time constant is 0.15, which is nothing but product of R and C. Our given time constant is 0.15 whole square into sine 80 plus pi minus the phase angle. So here it will be minus continuation minus tan inverse of 8 into 0.15 omega t. So output I0 equal to I1 plus I2. If I add the two components, so what I get is 1.9156 sin 2t minus 16.7 degrees minus 0.128 sin 80 plus pi minus 50.19. So here the correct option is D. Thank you.